Well, vertex and roots, this is probably the hardest one to look at in the big picture, okay? The vertex is a matter of rewriting this thing so it's in the equation blah blah squared blah blah whatever, y equals, okay? So to do that, we need to kind of sequester these guys, move the 24 over, and while we're at it, take out the 3. So I'm going to do that up here. Take out a 3, and I'm left with an x squared minus 2x. Well, I still have something to complete the square here. That's the b over 2 squared thing, but this isn't the b we should be using. It's that b. Okay? Don't forget you still have a minus 24 way out yonder here. Okay? Oops, sorry. I was referring to the equation to get the vertex, but the vertex should be in the form h and k in parentheses. So let me fix that first. b over 2 squared. Negative 2 divided by 2 is negative 1. Squared is a plus 1. To keep our scale balanced, we're going to turn around and subtract 1. But that's not just a 1 by itself. It's a 1 times 3. So I'm going to turn around and subtract a 1 times 3. Okay, so to clean this up, the equation I was referring to earlier here, 3 parentheses, x minus 1 quantity squared. That's a minus 3 and a minus 24, or a grand total of minus 27. That negative 1, negative 20, well, x minus 1 and a negative 27 means that our vertex is going to be at a positive 1 and a negative 27. Okay? You want to change the sign of the variable inside and keep the sign of the 1 outside. So to find roots, I need to factor, and the nice thing about this one is I can take out a 3, and I'm left with x squared minus 2x minus 12. And if I'm finding roots, I want to set it equal to 0. So this is pretty straightforward. Right, not minus 12. Phew. What I did is I looked at it and I saw there were no two numbers that multiplied together to get negative 12, but add together to get negative 2. But I factored out a 3 and got a 12. I should have gotten an 8. That's a little bit better. So minus 4 and x plus 2. My two roots are going to be what I get when I set those equal to 0. 3 is not going to give me a new root by itself, but anything involving x will. So x minus 4 equals 0. I have a positive 4, comma 0. And if I subtract 2 from both sides, I would get a negative 2, comma 0. These can be done the same way. I'll get you started. I would suggest taking out a negative 1. There's your plus 5. So you have an x squared plus 4x because I took out the negative. And so I'm going to get a plus 4 and then a minus 4, but that minus 4 is multiplied by a negative 1. So that's actually going to be a plus 4. I said I'd get you started. I'm practically done here. X plus 2 quantity squared. This is going to be a minus 9. Oops. Plus 9. So my vertex is going to be negative 2, comma positive 9. And in terms of the roots, I believe that's a trick question. No, it's not. If I take out that negative again, and it's probably a good idea to do that, I have an x squared plus 4x minus 5. Set it equal to 0. The negative 1 out in front doesn't do anything to my roots. Didn't even do anything to my vertex. It just meant the parabola is upside down. But this now can be an x plus 5 and an x minus 1. So my roots are at negative 5, 0 if I subtract 5 from both sides. Or 1, comma 0 if I add 1 to both sides. And you can either say a plus 0 or you can factor out an x. Your vertex is a lot simpler in that case. I'll let you have the honor and privilege of doing that.